For this problem, let's study the series summation n equals 2 to infinity, negative 1 to the n over natural log n. The first thing that should scream out at you immediately at this problem is the numerator, negative 1 to the n. This is an alternating series, and so we suspect that the alternating series test might be helpful here. So we use the alternating series test. All right, so to use the alternating series test, there's three things I need to check. So let a sub n be equal to 1 over natural log n without the negative 1 to the n. There's three things I need to check. Number one, a sub n is non-negative. Okay, so for if n is sufficiently large. And so that certainly happens here. If n is greater than or equal to 3, if n is at least e, then natural log of n is a positive number. So for n sufficiently large, the fraction here is going to be non-negative. Number two, a sub n is equal to 1 over natural log n is decreasing. For n greater than or equal to 2, since natural log f of x is equal to natural log x is increasing. The denominator is an increasing function. The reciprocal is therefore a decreasing function. Now, alternatively, so let me put an alternate way of doing this in pink. If we take a look at f of x is equal to 1 over natural log x, then f prime of x is equal to negative 1 over natural log of x squared times the derivative of the bottom, which is 1 over x. Okay, so positive, positive, negative, that's clearly a negative number. And so the derivative is negative, which means that the function is decreasing. Okay, so either way, it is decreasing. The third thing I need to check, the limit as n goes to infinity of a sub n. So the limit as n goes to infinity of 1 over natural log n. The denominator blows up. 1 over something that blows up, that goes to 0. Okay, so we've got all three things checked. The terms are non-negative if n is large enough. Now that 1 over natural log 2 is negative, but if n is big enough, it's non-negative. We have a decreasing function, and the limit of these terms goes to 0. And so therefore, summation negative 1 over n over natural log n converges by the alternating series test. Okay, now that's the end of this problem. The problem did not ask us to do this, but let me mention this for the sake of completion. This series converges conditionally. So I'm going to leave it for you to check that this series, if you left off the negative 1 to the n, then this series that involves just this without the negative 1 to the n will actually diverge. So the alternating series converges, but if I were to take absolute values of this, that would diverge. So this is a series that converges conditionally.